Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic, that is ambiguity of grammar, guys. So in the last lecture, we discussed how we can remove left recursion, right? Yes. So to be clear, left recursion is sometimes okay because we can understand, at least humans can understand. But when it comes to ambiguity, parsers will also hate this particular thing, guys. So if a particular grammar is ambiguous, none of the parsers are going to accept it. So none of the parsers will say that I am going to try at least. They are not even going to say that we are going to try. They are just going to avoid it, right? Yes. So these both are almost the same, guys. So left recursion as well as ambiguity. So both of these things are just not interested by parsing. Okay. Yes. So now let us discuss how we can decide whether a particular grammar is ambiguous or not. Because if we are clear with this, we can 100% surely say that for this particular grammar, parser cannot be generated, right? Yes. So that is the reason why this particular topic is a bit more important, guys. Okay. Yes. Okay. And I am being 100% clear when it comes to ambiguity. So when it comes to ambiguity, your observation and your concentration will matter here, guys, because here there is no processor. So when it comes to left recursion, I gave you one single formula and using that we solved everything, right? But here there is no such tricks. You need to solve it step by step. You need to analyze it because this is an undecidable problem. There is no formula, there is no algorithm, there is nothing here. You need to do trial and error method, or you should use your brain to understand the logic here. Okay. Yes. Okay. So what is ambiguity? I think I have already discussed about this, right? Yes. Anyway, let us revise it once again. So the grammar G is said to be ambiguous if there are more than one derivative trees for any input. So either more than one leftmost derivative tree or more than one rightmost derivative tree. So if we try for this grammar, so let me take a small piece of paper, guys. Okay. And let us start solving it. Okay. Yes. And in some moments, I'll be giving you some important tips also. So please concentrate, guys. Or yes, A or A. So now, let it focus, guys. Just give me a second. Yeah, it's okay right now. Yes. Okay. So when you have observed this particular, I don't know why this is that much focusing. Okay. Okay, so let it be. So S implies A, yes, or SA or A, right? Yes. So my assumption is I want to generate a small a or double A. So let us assume double A. It will be easy, right? Yes. So when it comes to double A, I think there are two different paths here, right? So from S, I can go to AS, or from S, I can go to SA. And in both the paths, I can generate double A, right? Yes. So what graph is this? So there are two parser trees possible for a particular request, right? So I want to generate AA either by using leftmost derivation. So assume that you are using leftmost derivation, you will get the same result. This is also leftmost derivation, you will get the same result. So left side you will solve first, guys. So 1, 2. So this is not possible to solve also. So this will be second. So 1, 2. Okay, so just by using this leftmost application, we are able to get the same result using two different trees, right? Yes. So now we can conclude that this particular grammar is ambiguous grammar, guys. Got it? Yes. So now what about unambiguous grammar? So unambiguous grammar means you will get only one parse tree. So if you can take this as an example. So assume that you want to generate a AB. So the only path is you can directly go to AB. So assume that you want to generate a double A, double B. So you will get A, B, yes. From yes you will get again A, B, yes. Okay, yes, in that way. So directly you will get A and B here. No need of this path also, right? Yes. So in that way, so this is unambiguous grammar. Okay, yes. So now most of the students are like, okay, so we are understanding some things, right? Yes. So grammar which is both left and right recursive is always ambiguous, guys. So this is a most important point. So if you see a grammar which is having both left and right recursion, you can directly conclude it is ambiguous, guys. There is no need of drawing this diagram also. Got it? Yes. But ambiguous grammar need not be left-right recursion. So that single condition cannot judge whether it is ambiguous or not, guys. Okay? Yes. So let us take this example. So if you observe this example, so let me write them down, guys, because if I am showing in the book, I will be seeing the answer and you will also see the answer, and it will just be not interesting, right? Yes. So let me hide the book and let me take down the questions. Okay. Yes. So yes implies yes, B, yes or A. So if you observe here we are having left recursion, here we are having right recursion, hence ambiguous. Okay. Moving on, yes implies A, capital B or small b. A implies capital A, capital B or small a. B implies capital A, B, B or B. So let us concentrate. So here, do we have left recursion? The answer is yes. Do we have right recursion? I think no, right? I think there is no right recursion. But anyway, let us try with some example, guys. Okay. So I think this is a tougher question, right? Directly. Yes. So anyway, let me explain you. So now if you observe this yes carefully, from yes I can directly generate AB, and from yes I can go to A and capital B. So now if I observe capital B, I can directly generate small b, right? So I will generate directly from B here. So indirectly for a single thing I got two different trees. Hence it is ambiguous. Got it? Yes. So in that way, so basically this is my observation, guys. So I have observed the question, then I have seen yes implies AB, and here I am having AB, and from B I can get B. So indirectly AB. So it's indirectly the same. So that is the issue which I have found here. Okay. Yes. So now let us go through the next example. That is yes implies yes A or AS or epsilon. See here. Here this is a left recursion and this is a right recursion. Hence ambiguous. I am writing AM for ambiguous, guys. Okay. Moving on. Yes implies double S or 0 or 1. So again left and right recursion. Ambiguous. Okay. Moving on. Yes implies yes A, yes or B. Again left recursion, right recursion. Ambiguous. Moving on. Yes implies yes A, yes B, yes or epsilon. So again left right recursion. Ambiguous. So now you're understanding, right? So how much is it easy to identify this now, right? Yes. Okay. So now let us try our next question. So the next question is yes implies yes AB or epsilon. A implies AAB or A. B implies AS or B. So now if I observe this question is really lengthy and I am able to see only left recursion, right? Yes. But I observed a few things here. I can substitute these two things in the above equation and I can get some things, right? Yes. So let us concentrate for some time, guys. So let me update the first S in this way. So yes implies yes. So I can keep in place of A, I can keep this value or this value, right? So let us keep this value first. So it becomes AAB. So the other path is this, right? Yes. And now in place of B also I can place this or this. Okay. So let me repeat these things first so that will be easy for us. Okay. So if I keep AS here, it works in this way. AS here and the other option is B. I wrote all possible combinations with respect to that, right? Yes. So now our yes is indirectly in this way, right? Now if you observe left recursion, right recursion, left recursion, right recursion. So indirectly this is also ambiguous. Got it? Yes. So now I hope everyone is understanding, right, how exactly we are solving it. We are using only one single rule till now, guys, just based on this left recursion and right recursion problem. Okay. Yes. So if that fails, let us try some other methods. Okay. Yes. So the next question is yes implies ASB or BSA or epsilon. Okay. So now here there is no left recursion nor right recursion. So now I am struck by checking examples. So now the only option for me is left out is examples, because it's a single line, there is no substitution and all those things, right? Yes. So one path says that it is going to give A first and B last. The other path says that B first and A last. And the other thing is epsilon. Okay, so now I think this particular thing is not ambiguous, guys. You can try generating few strings, because by observation only we can conclude this, right? Because there is no chance that you can get two same things using different things, right? Yes, because it's coming in the opposite way. So if I use A, I will get a B. If I first want a B, then I will get a. Got it? Yes. If you want, you can take some examples and you can test, guys. To be clear, to say something is ambiguous, we can show this left recursion and right recursion, but to prove that is not ambiguous, it's really tough, guys. Okay? Yes. Okay, so let us go through the next question, that is A implies A open bracket A close bracket or A. Okay, yes. So most of the students will be blindly thinking that here there is a left recursion and this is the right recursion, but here on the rightmost thing it is closed bracket, guys. It is not A. So this is not the thing, this is the end. So indirectly here there is no right recursion, guys. Okay, yes. Okay, so now the only option for us is, as it is not ambiguous till now, so let us take some examples. So if I want to generate AA, okay, so anything if I generate, so it will come in this way only, right? Or I can generate multiple things here, so basically you can write it in this way. But I think I cannot generate same thing in two different ways. So I think now this is also unambiguous, guys. Okay, if you want, you can take some examples in the same way and you can test, guys. Okay, yes, okay. Okay, so let us continue. So the next question is yes implies L/A L implies L comma S slash S. So is there left recursion here? Yes. Is that right recursion? No. So now the only option is, so let us substitute this L here, guys. Okay, but here there is a huge recursion, right? So this S is going to repeat this S again, okay. But if you observe here carefully, there is a small catch here, guys. So however you substitute, this bracket is going to be at the end and this bracket is going to be at the start. So indirectly this S will never have recursion, right? Yes. So with that analysis, we can conclude that here there will be no left recursion or right recursion, right? So this is here it is having left recursion, but for S it is not having left or right recursion, right? Yes. And even if you substitute that S values here also, you are not going to get right recursion. So I think using left and right recursion, we cannot conclude about this. So if you want, you can test, guys. But this grammar is also unambiguous, guys. Okay. So if you want, you can try with some diagrams and you can cross check it. Okay. Yes. Okay. So let us try the next one. That is S implies yes, S or A. Left recursion, right recursion, ambiguous. Moving on. S implies a 0 S1 or a 0 1 S or epsilon. So to be clear, it looks like unambiguous, right? Because here we are having only right recursion, but there is no left recursion. But if you observe these two things, there are a lot of similarity. So from S I can generate a 0 S1. From S I can generate a 0 1 S. So from S I can go to epsilon. So from S I will go to epsilon. From S I will go to epsilon. So here I am going to get 0 1. Here I am going to get 0 1. So indirectly that is ambiguous, right? Yes. So now you understood, right? So a grammar which is not having left and right recursion can also be ambiguous, and a grammar which is not having left and right recursion may be unambiguous also. Okay, so that is the reason we should check with some examples, guys. Okay, yes. Similarly, S implies A, capital A, B. Capital A implies a small a, capital A, or B, A, or A. Similarly, B implies a capital A, or B. Okay, so now I think we can do some thing here. Okay, yes, okay. So I observed one thing here. So if I substitute this value here, what will happen, guys? So this value will be updated to A. So indirectly A implies this. So it is left recursion and right recursion, hence it is ambiguous. Got it? Yes. So this is the only trick which I can say, guys, because that's the only trick available, right? Yes. So now I hope everyone is understanding, right? So how exactly we are concluding these things? Yes. Okay. Similarly, if the question is S implies AA and A implies AA or B. So few students might be thinking that this is ambiguous, but this is yes, this is A, guys. These two are having no relation. When it comes to here we are having only right recursion. So there is no left recursion. So indirectly this is also unambiguous, guys. Okay, if you want, you can take some cases and you can try. Okay. Yes. So are there any questions? I think these are all the questions which are directly given in my book, guys. Okay. Yes. So now I hope everyone got a clear idea with respect to ambiguity, right? So I think we spent around 12 minutes to 13 minutes on this particular topic, but I think everyone got a clear idea on this particular topic, right? Yes. And there are every 1-2 years we get at least one question from this ambiguity, guys. Okay. Yes. So that is the reason why please practice with respect to ambiguity. Okay. Yes. So in the next lecture, let us go through the next thing, that is a non-deterministic grammar. So when can we say that a particular grammar is a non-deterministic grammar? Okay, yes. So in the next lecture, we'll be discussing about it and we'll be taking some examples, guys. There will be very less examples with respect to this. And once this lecture is done, we will be discussing about the simplification of minimized context-free grammar. So how we can minimize the number of statements or number of productions in a grammar. Okay, yes. So in the next lecture, let us discuss about this non-deterministic grammar. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.